Hello everyone! I'm really happy to be here and participate in the event. I know that there are other teammates and other people participating with great sessions, also great sessions about .NET MAUI, doing a global vision about what is .NET MAUI, what offers, what are the main features, etc. So in this case, I'm going to put the focus in see what are the different ways to create and customize the UI with .NET MAUI. First of all, my name is Javier. I'm software engineer at Microsoft working in the .NET MAUI team, and here you can find different ways to contact me. Please, if you have any question about the session or I can help you with anything related with .NET MAUI, I'm more than happy to help you with anything. You have here my email, my Twitter account, just ping me and I will try to help anything. So let's see what is the agenda. What are we going to see? So first of all, we're going to see how to reuse code from Xamarin Forms, continue using the Xamarin Forms architecture with the custom renderers, and reuse that custom renderers with .NET MAUI. Then we are going to explain and see why we are changing in .NET MAUI the custom renderer architecture by handlers, the new custom handlers architecture. What are the main reasons, what are the differences, and what are the benefits? So we are going to see, of course, how to create custom controls using handlers. Then we are going to continue with different ways, other approach, not using directly, the mapping between the abstraction and a native control. And we have other alternatives like use a content view, use a template view. In this case, we are using a composition of .NET MAUI controls to create another control. The template view is a really interesting one because we can create templated controls where we can swap and change the template and create something totally different. Of course, we are going to see that. And finally, we are going to see a totally different approach using drone controls. Instead of create a native control, we are going to use a canvas where we are going to paint and draw the necessary to replicate and create a. We are going to see all the options with pros and cons, what are the good things about use this approach and the bad things. And finally, you will have a questions and answer section where you are able to ask anything. So let's start. But first of all, before see the different approach that we have to create .NET MAUI controls, I want to stop very quickly to talk about what is .NET MAUI. .NET MAUI is the cross-platform framework for .NET. It's an evolution from Xamarin Forms. So you can create the UI using XAML code and also using C# code, support desktop and mobile platforms. The supported platforms are Windows, macOS, iOS, and Android. Windows is supported using WinUI 3, while macOS is supported using Mac Catalyst, and of course Android and iOS are using .NET for Android and .NET for Android. There are also chains in the tooling. Now we have only a single project grouping all the platforms. We have command line support to create, compile the projects, etc. The type of the project is now an SDK style project, and of course also we are using .NET CIS to use all that. There are some basic namespace that change from Xamarin Forms to .NET MAUI. The main change is Xamarin Forms to Microsoft.MAUI. And the default approach of .NET MAUI to create the UI is use abstractions. At the end, .NET MAUI offer an abstraction that allows you to create the UI with a single code base, mapping from this abstraction to native controls. So .NET MAUI use that abstraction to define the elements and then transform, offering an implementation and mechanism on each platform. Let's start seeing what is probably the main idea that you will have if you already have a project or some controls, some libraries working on Xamarin Forms, and you want to reuse and port a big part of that code to .NET MAUI. So we can create controls using the custom renderers approach. It's the same approach used in Xamarin Forms. At the end we have two parts. One part is the element that describes the abstraction, the control in the abstraction. For example, the button has properties like the text color, etc. And then we have the renderers. The renderers are also some classes that create the native control and maps between the properties in the abstraction and the native control each platform. So for example, the button, it's using a MAUI button in iOS, etc. To make the transition from Xamarin Forms to .NET MAUI as smooth as possible, we included a compatibility layer that is not more than a subset of the Xamarin Forms custom renderers APIs to allow you to reuse all that code from renderers without requiring to make big changes. At the end, the idea is that you can reuse all the code of the renderers with exactly the same API, only changing some namespace. So let's take a look. Xamarin Forms user interface and also .NET MAUI user interface are rendered using the native controls on every platform. To do that, we start with an abstraction. So this is the first step, creating, for example, an entry. It's used to create a box where we can type test. It's create a class with the abstraction. Then we need to create one renderer by every platform. All the renderers use the view renderer base class that it's allowed to map between the abstraction and the native control, and we have two main controls that are on element chain, that is the method where we usually instantiate and create the native control, and on element property chain, where we will receive a notification every time that a property changes, and in that way we can get the change from the abstraction and notify and update the native implementation. This is the default implementation in Xamarin Forms, and as you can see, we can reuse exactly the same code in .NET MAUI, just changing some namespace. The namespace from Xamarin Forms to Microsoft MAUI controls, and all the namespace inside Microsoft MAUI controls compatibility. Here is where you will find all these view renderers, etc. The other main change is related with how we register the renderer, because while in Xamarin Forms we was using this sport renderer attribute, now in .NET MAUI that changed, and I'm going to talk about that later, but it's related with performance. Now we are going to use the MAUI program class, that is one of the most important class in .NET MAUI project. Is the class that will be able to start the project, where we can initialize the application, register services, register handlers, etc. So we can use the add compatibility renderer method to map between the abstraction and renderer. And in that way, we can just register a renderer. So this, of course, has pros and cons. The pros is that we have a good performance because we are using a native control, and we can extend all that native controls, taking advantage of it and using the native APIs and all the possibilities of native code. But also has some cons. It requires more code than other options that we are going to see today. Requires also native development skills on each platform. For example, to create the button, we need to know the UI button, specific APIs to, for example, I don't know, a gradient, etc., etc. And also extending also requires, of course, knowledge about native development. Let's see a quick demo about that. So this is our demo. In this case, we are going to use checkbox. It's a simple control, easy to see, with use a few properties and easy to understand. We have different checkbox in the screen. I can just mark all of them, and you can see that in many cases are exactly the same control with the same options or pretty similar. But the interesting thing here is like we are doing all these checkbox in a really different way. We are going to start with the handlers renderer approach, and to that I'm going to put the focus on the first of all that approach that is using a custom renderer. For that, I'm going to show first of all the first part, the element that is used the abstraction that defines our control. A checkbox in this case for us is a view that implement two bindable properties. One of them, that is the main property, is checked to detect if checkbox is checked or not, and then a second property called color that is used a property to fill the color that will be used in the checkbox when it's marked. So that are the two main properties, and then in a .NET MAUI project that is a single project, we can use the platform folder where we have different folders for every platform. And as you can imagine, the code that we put inside the platform's Android folder will only be compiled and used by the Android platform, and the rest of the same happens with the rest of the platform. So here we can find the custom checkbox renderer control. In this case, we inherit from the view renderer class where we set that we are going to use our abstraction, and the native used control will be the app compact checkbox. We have two main methods to override. One of them is the onElementChain, where we are going to instantiate the native control, and the other one is the onElementPropertyChain, where we are going to detect if any of the properties change it, and if, for example, the property that changed it is checked, we can use map and update the native controls from the abstraction. Really easy. And then the only thing that we need to do in a different way, because take a look here, I'm not using, the sport renderer attribute, is use the host builder. My recommendation in this case, mostly if you are creating a library, is create an extension method. You can create an extension method like this, where I'm going to receive the host builder, and you can inject here, enumerations, booleans, a class with different parameters, etc. to configure your registration. In this case, I'm just using a boolean to determine if I'm going to register and use the renderer, or I'm going to use and register the handler. Based on that boolean property, in this case, if I want to register the renderer in Android, I'm going to use the add compatibility renderer, registering the custom checkbox with the custom checkbox renderer. That's all. From Xamarin Forms, all the chains are this namespace from view handler that it's different from Xamarin Forms that previously was in the Xamarin Forms platform namespace, and of course the Xamarin Forms namespace itself is changed by Microsoft MAUI controls namespace. The rest is mostly the same code, the same API, the same methods on the element chain, on element property chain, and I can use that way to create my own native controls. The second approach is using custom handlers. But what is a handler, and why we are changing the custom renderers architecture by this new one? So let me talk very quickly about we switch from renderers to the .NET MAUI architecture. There are a few points mostly related with performance, extensibility, etc. that we learn with the pass of the years creating and developing Xamarin Forms. And one of the first point is like in Xamarin Forms, the renderers are tightly coupled to Xamarin Form component. So a button renderer is mapped and using a Xamarin Forms button. That's not a big problem until you want to allow to swap and use any other implementation in an easy way. So this is something that we really wanted to improve with performance. And to register the renderers, we use the sport renderer attribute in Xamarin Forms. Internally, what was happening here is that Xamarin Forms at the startup time was using a simple scanning to ask and reviewing all of your reference if there are any sport renderer attribute. There is a sport rendering attribute here, there is a sport rendering attribute here. If find one of them, just take it and use it to register the renderer that you created, but a simple scanning is very slow and of course have an impact in the performance, mostly in the startup time performance. And then the other thing related with this is like access to native code from cross-platform layer, from cross-platform code. It's complex. It's complex and sometimes it's not clear how to do it. So that's why we changed it that with plus other options like some APIs create some kind of confusion. Like for example, with the renderers, we was using, the element chain method that use sometimes the new element or all element properties, and that causes some confusion. Like when I should use what and when I should subscribe, don't subscribe some event, etc. So with all that in mind, we created a new architecture that have 3-4 main chains in mind. One of them is like now the dotnet-maui handlers use interface to manage the abstraction, the type of the control. We also not use a simple scanning to register this handler. And also there are big changes in the API with the main goal of create a more easy API to learn and to progress creating kind of controls. And finally, of course, the extensibility is really important. If you remember our custom renderer, we are using, an private method to date and map, if the checkbox is checked between the abstraction and the native platform. That's private. What happens if you want to extend and override the behavior that happens when this checked property change? So many cases that force you to copy some big handlers and use update and replace some small piece, and we really want to avoid that. So create a handler is as easy as the following. First of all, we create the control specific interface that must derive from the iView interface. iView gives to your interface of the basic properties from a view, the width, the height, etc., etc. This avoids the cross-platform control to have a reference in the handler, and this avoids the cross-platform control having to reference its handler and also the handler having to reference the cross-platform control. Then, after create interface, we will create a handler class for each platform. This handler class must inherit from the view handler class. And here we have another really important chain, because while in Xamarin Forms we was inheriting from the view renderer class, and for example in Android that was creating a parent view, in this case in Android a layout group that was doing some stuff related with layouting, sizing, etc. In dotnet-maui, using the view handler class, we are not creating any parent view wrapping the native control in any way. And also that reduces the view hierarchy and improves the performance. Then there are some important changes at API level to avoid the confusion with on element chain or element property chain. When create that, there are some really clear and basic methods like create native view, where we are going to instantiate and create the native view in the create native view method. And finally, we have another new concept that is the mapper concept. This is a new concept introduced with .NET MAUI. It's nothing more than a dictionary with properties and actions defining the interface of the control. Remember that we now use interface, and this replaces everything that we had before in the element property chain method. But also you are mapping your properties to some public static methods, so it's easy to know, and if you want to override or change what it's mapped when, it's as easy as access to the mapper and change what you want to do in one specific property when one of the property changes. And also it's more easy also to you in case, and also for contributors to know where are all that parts of the code, and all that piece of code are now public methods, so you can use extend, etc. in a easy way. The final part, of course, like before, is register the handler using, in this case, the add handler method in our app host builder. What are the pros? We get a very good performance. We are using native controls, but also we are getting better performance than using the previous option that was using the custom renderer. Why? Well, mostly because we are not getting that parent view, and also the layouts use a more strict way to manage this kind of controls, use reducing when do you do a measurement of calculate the sizing, positioning, etc. Also, we can allow the sensibility in a more easy way using the mapper and taking advantage of the capacity and possibility of both. The cons are pretty similar to the previous approach. Requires more code, another option that we are going to see today. Requires native development skills on each platform, because at the end we are mapping from the abstraction to native controls in each platform. You need to know how the native controls work in every case. And then extending also requires, of course, knowledge about native development each platform. Let's take a look to see how we can use custom handlers. Back to my demo code, we have here the definition of our checkbox. This case is use an interface that inherits from iView, and then we are creating a handler that is a class where we have the mapper that is mapping from a property from the interface to a public static method. For example, in Android, this public static method it's here, and we have here a class that is using the view handler. Remember that now this class is not creating a parent view. We are mapping from our interface to, again, an app compact checkbox. There are APIs that are more easy to know and to detect when to use what. For example, when we are going to instantiate and create the native control in the create platform view, we are doing the pretty similar what we was doing in Xamarin Forms in the on element chain method. But we have other methods to, for example, when the handler is connected and disconnected, that they are the best place to put code like registering and unregistering, etc. Instantiate and take some resource and then free that kind of resource, etc. So all the code from an element chain is split in different methods, more easy to follow and understand. And then when we are mapping, the abstraction to the native control, everything is public. So you can access to all this stuff in any moment, and you can override also what's the behavior that will happen when you are mapping this property in a easy way using mapper. So pretty similar to the previous way, but using the new APIs, the new dotnet MAUI architecture, it's better in the way that we are not creating a parent view, a necessary parent view to do layouting stuff, and also it's really interesting because we allow more options in the extensibility way, etc. For the rest, the approach is the same. We are mapping from one abstraction to native controls. Let's continue and see other kind of ways to create controls in dotnet MAUI. And the third way to create a control is using a content view. Content view is a type of layout existed before in Xamarin Fonts and continue existing in dotnet MAUI that contains a single child element and is typically used to create custom controls. The process to create a custom control in that way is, first of all, create a new class that inherits from content view, then define properties and events that you need in your controls, and finally define the user interface in the same context. To consider, first of all, to get the best performance using this way, you need to think really well about the hierarchy that you are going to create using the control, because as higher the hierarchy is, the greater the negative impact is on the performance. So just only create the elements that you really require to create your control, and as possible, try to free up resource as possible. The pros and cons, it's really simple to create. There is no platform specific knowledge required because everything is built with dotnet MAUI abstraction. Define the control only once for the platform, while in all the previous options you need to create code for each platform. Here is created one for all platforms, and the cons are mostly related with the performance. So if you define a control in this way, for example, your control require 5 dotnet MAUI views, for example, 2 lines, 1 ellipse, one text, etc. It is required to instantiate those 5 views with a performance. Let's take a look to see how we can create our checkbox using a content view. So back again to our code, we have here our content view checkbox. It's a content view. The content view here is creating the code necessary to draw the UI. It's a grid that contains a rectangle and a path. The rectangle will draw, the border or the appearance of the border, while the path will draw the glyph used to the check when we are checking the checkbox. So here we are using a tap gesture recognizer. Again, this is cross-platform code, so it's a cross-platform tap gesture recognizer, a recognizer from dotnet MAUI. Define or bindable properties to define the aspect and the behavior of the control, and then when we are tapping, we are just changing the glyph and we are changing the checked property. We can, of course, animate and do different stuff to improve the look and feel of our control. Taking a look to our control is this one, where there are some small animations when we are tapping and we are changing the feeling of the control, etc. Let's continue with another approach that is just a step forward from this, but have also some benefits, and are the templated controls. And to create templated controls, we are going to use a template view, because it's really important to allow to customize as much as possible. But think about that. With the good specification of a control, just creating as many properties and events as possible, we can cover most of the requirements of that control, but will be mostly impossible to cover all the case, all these scenarios, right? Let's take an example. In our checkbox, we can add a property to customize the border color, but what happens if then someone wants a dotted border? Yeah, I know the answer. Okay, we can include another property, but then what's happening if someone needs, what's happening? It will never end, because someone will require probably a really crazy specification with a really specific case for their application. How we can solve this scenario? How we can improve this? We can improve this using control templates. A control templates allow to define the visual structure of the control. The extensibility in a easy way with many possibilities because we have brushes and shapes API, so we can allow to draw anything and paint anything in different ways. And if we think about that, for example, how will you create a slider? At the end, it's use a line with an ellipse that we can move. And how we can create our checkbox? At the end, is use a rectangle to draw background along with the markup indicator, right? So a templated control, it's a control that use the templated view, dotnet MAUI view, and contains an element that is called content presenter, often used with control templates. That is an element that allows to insert content at runtime. And with that content presenter, we are going to also use the template binding markup extension that binds a property of an element that is in a control template to a public property defined by the custom control. After a control template has been instantiated, the onApply method is invoked. And in this method is where we can use another method that is called getTemplateChild to get access to the different views that compose the control in case we want to access to it, or I don't know, change some properties or animate something, etc. The consideration to have here is pretty similar to the previous one. First of all, do not create elements that are not necessary in the template. To remember that. Also, the control template elements are typically accessed for generic operations related to ascending sizing, positioning, or basic properties like color. So you can use basic elements to that. In that way, if the template is modified, it will not have any kind of. And do not access an element that the template. Do not access elements from the template if you are not going to use them. If you are not going to do anything with them. Color, change a property, etc. What are the pros and cons? The pro is pretty similar to the previous content view option. It's really simple to create. There is no platform specific knowledge required, so everything is built with the dotnet MAUI abstraction. It's really great, it's really fine. And also we are going to define the control use only once for all the platforms. That's also amazing. It's allowed not only to customize the control via properties, the color property, but also we can access the template and modify anything that we want. That's also a really good point. The cons are pretty similar in this case than previous case, and only remember that if to compose your control you require 10 dotnet MAUI views, you are going to instantiate that 10 with the performance. Let's take a look to a demo. So this is our content view checkbox. Let's leave that behind and move to the templated checkbox. One of the main changes is that instead of use the content view class, we now use the templated view class, where we define in this case all the UI, in this case in a control template. Here we are going to use, for example, a rectangle and a path, allowing also a content presenter that will be, for example, text of the checkbox if we want, or anything else. And when we instantiate this control, the main method that is used is the onApply template, where we can access using the getTemplateChild to the views that define and compose the template. With that views, we can, like before, use, for example, a tap gesture recognizer to detect when the user is tapping control to change, the colors, opacities, animate anything, etc. If we go to our sample, we can see that We can create controls using template view, but we can change totally their aspect. In this case, we have here an ellipse instead of a rectangle, and the checked indicator it's totally different. So how we have done that? In our main page, we created another control template. We override the rectangle by an ellipse, and we change the path with a custom path that we want, changing also, other aspects like the stroke, the size, etc. The only thing that we need to do to use this custom implementation, this custom aspect to our checkbox instead of the default one, is use this key, and in templated checkbox use the control template property that all the templated controls have, all the controls that inherit from template view, and assign this new template to the control. That's all. Really simple and really easy. Finally, we have the option to create drone controls. And to create drone controls, first of all, I need to talk about Microsoft MAUI Graphics. It's a new library included with .NET MAUI. It's a cross-platform graphics library for all the supported platforms by .NET MAUI and the other ones, completely writing in C#. With this library, you can use a common API to target different abstractions, allowing you to share your drawing code between platforms, having the possibility to create and draw from basic shapes to more complex stuff like shadows, etc. In .NET MAUI, a new control is included, Graphics View, which exposes a canvas where we can draw anything using Microsoft MAUI Graphics. So let's see how we can create a control using Graphics View. First of all, we need to create a class that inherits from Graphics View, and Graphics View have a main property that is drawable. A drawable is a class that inherits from iDrawable. So we need to create a class that inherits from iDrawable, that like this checkbox drawable class, that has one main method that is draw. We need to implement this draw method that, as you can imagine, is where we are going to draw. In the draw method, we receive the size of the canvas that we are going to use, and of course the canvas. With the canvas, we have many extension methods that allow us to draw different aspects. For example, we can draw a rounded rectangle with the method draw rounded rectangle. But to create controls, we also need some kind of manipulation. We need to manage the user input, and to do that, the graphics view controls expose all the main touch interactions with the control in a easy way. For example, we can detect when an interaction is starting, so when the user is pressing the control with the start interaction method, where we are going to receive the touch event arch argument that will contain information about the touching points, where the user is touching, if he's touching with the fingers, etc, etc. So create controls with MAUI graphics, we use mainly use of the canvas, where we were going to draw all the control. MAUI graphics and the graphics view allow us to manage not only the drawing aspect, but also the user interaction, and to customize the behavior and customize the aspect. Again, we are going to continue using bindable properties. Remember to take into account, for the best performance, avoid using multiple canvases to create your control and draw as much as possible on a single canvas. And when creating controls, you can use a graphics view as the base element instead of create, for example, a content view and include the graphics view inside the content view. If you don't need to compose, if you need to include some native buttons with, the canvas and something more complex, of course, that's fine, you can do that. But if you only need the graphics view as child of the content view, please forget that and remove the content view, include the graphics view directly. So what are the pros and cons of this approach? Well, the pro is that we are drawing directly on a canvas, and I mean, with the possibility of using the GPU, and this is very high performance. You can get a really great performance. You want to create a control that really requires to update very quickly or do a lot of operations, updating many things at the same time. This is really a good approach to go. And also, like other of the previous approach, you only need to define the control only once for all the platforms. The cons is like you are not using native elements here. We are drawing everything on a canvas. So we are not going to allow to extend the control using native APIs, like for example, we have with renderers or handlers. And also requires knowledge about MAUI graphics API. It requires to know how to draw rectangles or to draw shadows, etc. So let's see a demo using graphics view to create our checkbox. Back to our sample, we are going to see the drone control here. It's a control that inherits from graphics view, where we have, all our bindable property, and then we have a drawable with the draw method, where we are going to draw the background that is use a round rectangle, and then we draw the checks that is not more than a path that we have defined here to draw the check. If we want and need interactions, we can use different events like static interaction. There are a lot of more methods like drag interaction, start over, end over, move over. There are many possibilities to detect exactly what's happening and what kind of interaction is doing the user. If we go to our demo, this is our drawing checkbox. It's pretty similar to the previous one, but all these controls are using native controls, while this control is totally drawn by the code that we define. So I'm going to use the agenda to do a very quick summary. We have seen how to create controls using custom renders and custom handlers. The concept is pretty similar, but the handlers are the new architecture and have some benefits, mostly in performance and extensibility. We have also seen options to use a single code base with content view, template view, and graphics view. Content view and template view is pretty similar, but template view is more powerful because we can allow to change the template and customize anything inside of the template. While the final option, the graphics view, is another approach, totally different. Instead of use native controls, we are drawing everything in the canvas. Now it's time for questions and answers. Okay, that's all. Thank you all for joining, thank you all for watching these sessions, and I hope that has been really interesting for you. You learned something new. Remember that you can contact me on Twitter, via email, or anything if I can help you in any way. And thank you all. See you soon.